This question asks us to predict whether this reaction will be an E1 or an E2 reaction and to draw the mechanism for it. We have a secondary substrate, a secondary alkyl halide. Secondary alkyl halides can either do E1 or E2, so that doesn't really help us here. What I notice is that we have sodium ethoxide, a strong base. As a strong base, it doesn't have to wait around for a carbocation. It can directly attack the beta hydrogen in order to form the E2 reaction. So this reaction will go through an E2 pathway. In an E2 pathway, the base directly attacks the beta hydrogen. I have the beta hydrogen drawn in here. There are 2 beta carbons in this molecule, one on either side of the alkyl halide. Zaitsev's rule tells us that we'll form the most substituted, most stable alkene product. So we will take this beta hydrogen. The ethoxide then can use a lone pair of electrons to attack the hydrogen. That builds up too much electron density around hydrogen, so we break the carbon-hydrogen bond, forming the alkene, using these electrons to form the pi bond. That builds up too much electron density around this carbon, and so we'll break the carbon-chlorine bond, pushing those electrons onto the chlorine to give the chloride leaving group, forming our alkene product. This is the mechanism for this E2 reaction.